Hello friends of the channel. Welcome to a new video where we will talk about AutoGen Studio, a tool that allows you to create agents and workflows very quickly using Azure OpenAI. My name is Hector Perez. I am a Microsoft MVP. Before we discuss what AutoGen Studio is, we need to know that AutoGen is essentially a framework created with two questions in mind by its creators. The first question is, what is the future of artificial intelligence applications? Or what would these types of applications look like? The second question is, how can this power be given to all developers to create these kinds of applications? These are the fundamental questions behind the creation of this framework. Basically, this framework is a multi-agent conversation framework that provides a high-level abstraction for creating multi-agents. With this framework, LLM workflows can be created very quickly and easily. It serves to create various applications as it offers a collection of workflows covering a wide range of applications that you can build across multiple domains and complexities. You can create as many workflows as you want very easily. It also allows for improved optimization and inference for LLM. Inference APIs for LLMs are supported, which can be used to improve performance and reduce costs. This is because, in addition to using Azure OpenAI or OpenAI, you can also utilize local services or other third-party models like Gemini, among others. Before applying these concepts in AutoGen, we need to know what an agent is. When you hire someone to join your team, you are hiring someone with specific skills. When you assign a job position to that person, you are essentially assigning a set of roles, responsibilities, and tasks that the individual will carry out. It is dedicated solely to executing the series of different operations you assign to it. So, if you assign, for example, a person to write an article about Bill Gates and Microsoft, and you say they only have half an hour to write it, well, they might start writing very quickly. It is very likely that the article will have errors such as spelling mistakes, poor phrasing, and possibly mixed up ideas. Because the person doesn't have the time to carry out all the tasks of reviewing, correcting, searching for information, etc. The same thing happens with an agent or when you interact with ChatGPT and you give it a very long prompt to perform an operation. Generally, the LLM or ChatGPT can have problems like writing incomplete articles or having hallucinations, since we are not giving the agent or LLM enough time to perform a series of error correction operations it might need. So, the same thing happens with both humans and agents. Imagine then that you could hire a series of people to perform specific tasks. One person to search for information online, another to correct the article, another to create the initial outline to know which ideas to convey, another to write introductions exclusively, another to write conclusions exclusively, and another to create the most interesting data. With this, each person would have a defined role and be specialized in that specific role. Well, we can do the same with the agents. Basically, you can create many agents that represent people, each with a specific role. The big advantage is that you don't have to hire a series of people. You can define the roles for each of the agents in AutoGen so that each of these agents essentially carries out a specific task for which they have been trained and instructed. So, AutoGen is this framework that will allow us to build these agents. Basically, one of the advantages is that we have the customization of agents. We can customize these agents as much as we want. Here we see an example, for instance, where we have 3 agents. The first one has access to ChatGPT or OpenAI models, for example. It also has access to converse with the user. It has access to some tools. We see that the second agent has only access to ChatGPT. The third one can write Python code and also interact with humans. So we customize the agents according to our needs. We also have this multi-agent conversation section, which basically allows us to establish a conversation between different agents to discuss among themselves and obtain the best possible results. Today, many conversation patterns already exist that allow these agents to interact in some way. So, for example, in the next slide, we'll see an example of how this kind of workflow occurs, this type of information flow between agents. You should know that in AutoGen there is something called a user proxy agent, which is essentially the representation of the user who initiates a conversation. One of the default abilities of this agent is that it can also take the role of executing Python code on your local machine. That's very important and interesting because if you use ChatGPT, you know that before the latest updates, you could only generate the code, but you had to copy it and execute it locally. The great advantage of AutoGen is that you can use the Python code returned by an LLM and have it automatically executed by the agent to see if there were any errors or if the execution was successful. So, we see that the user proxy agent represents the user who can execute Python code. We also have a second agent, the assistant agent, which is configured through an LLM to write Python code. Unlike the user proxy agent, this agent only generates Python code. It does not execute it. This is very important. It sends the Python code, and the user proxy agent is responsible for executing that Python code. Here we have an example of a chat conversation where the user proxy agent indicates, "Okay, I want you to make a graph of Meta and Tesla stocks or show the changes that have occurred." After that initial prompt, the assistant agent, which is the LLM representation, tells you that you need to execute the following code. It responds with Python code, and the user proxy agent executes the code. However, as part of the message output, it indicates that there was an error because the gfinance package is not installed. Next, the assistant agent makes the necessary corrections based on the log messages sent by the user proxy agent, according to the execution. It says, "Okay, it's not working because the message says you need to install yfinance. Once you install it, re-execute the code I sent." Then, the local agent installs the package. Once it can execute the Python code correctly, it shows the final result. But the user intervenes once more and says, "Okay, I don't want you to print it out like this. I need you to change it into percentages." So, what the assistant agent does again is send a revised version of the code showing us the output with the data in percentages, as previously requested. Basically, this is the AutoGen flow, a series of chat messages where various agents interact to complete a final task. Initially, AutoGen, this framework, is created for writing Python code. Here we see some configurations of how this Python code would look. Some configuration options, such as whether the user has the option to intervene or the option to execute code locally. These features or properties are assigned to each agent according to our needs. We see that the user proxy agent has the capability for the user to always intervene. The conversational agent has some associated tools. We even have features like a chat manager, group administrator, or a chat group, where different agents are assigned to have a conversation among themselves to execute a task. This group chat manager would be responsible for orchestrating the conversation to decide who should intervene next. Here we have the chat representation we saw earlier, but in a diagram format, showing the flow of information as illustrated in this diagram, indicating the exchange of messages between the user proxy agent and the assistant agent until reaching an operation called terminate, where all messages are written or sent and received. Now let's talk about AutoGen Studio. Basically, AutoGen Studio is well, the description here says it allows us to create multi-agent prototypes very quickly or rapid solutions. AutoGen Studio was created by the AutoGen team, which allows us to define and modify agents with a drag-and-drop interface. We can drag-drop elements, configure them by clicking on different parameters, and it is very simple software. It also allows us to create chat sessions with specified agents and see the results in the same chat window. With all this information, we'll see an example later. It also allows us to explicitly add skills to agents for them to perform more tasks and enables us to publish sessions to a local gallery. So, with all this said, let's have a practical demonstration. Before this demonstration, I would like to quickly show you the main AutoGen website. Let me search for it, please. Okay, here it is. And basically, this is the main AutoGen site. It says it is an open source programming framework for AI-based agents. So we have all the documentation here. If we go to the Getting Started option, we see that it takes us to the AutoGen documentation. You can see that on the left side, we have a lot of tutorials, a lot of information that can be very useful if you want to specialize in this quite popular framework. We are interested in the section that says AutoGen Studio, which basically gives us information about the software and, most importantly, provides the installation instructions to install this framework. You also have this other URL available, which is autogenstudio.com/AutoGenStudio This basically shows you a simplified way to perform the installation here using Conda, which allows you to create an environment, essentially an environment with AutoGen. Then you activate this environment and you can start using AutoGen Studio with the command you see on the screen. Once you have done all this, you will be able to use it as part of your operating system. The important thing here is that once AutoGen loads, you have different sections to try AutoGen. At the top, you have the Build section and another section that says Play Around. The Build section allows you to configure tools, models, agents, and workflows. Let's see what each of these options is about. First, we see the option called Skills, which basically represents an ability you can give one of the agents to perform an operation it doesn't have by default. For example, if you want to create an image, you can give this ability to an agent to perform this action. We know that for creating images, we have a lot of models, a lot of services we can use to create images, we can create videos, PDFs, Word documents, etc. So, all these skills can be defined here to provide them to an agent so the agent can use them. How do we do it? We click on the button that says New Skill, and notice that on the left side, you have a section where you can write the Python source code. Here, one important thing is to ensure that this Python code first executes correctly on your local machine, that it has no errors, and that it always returns something so the agent can work with that output and perform another operation if it needs to. You can define the name of this skill, and an important thing is to correctly define the description, as this description is what AutoGen uses to select the tool needed to perform a certain action. Here we have a set of different skills, such as generating images with Azure OpenAI. Here I have a piece of code. As I mentioned earlier, since it's code that runs locally, you can have features like environment variables, and it will work without issues. This is to avoid showing, for example, an API key. We have the code here, and notice that I'm defining this skills description. It could be a bit better described, but I'll leave this description as it is. I have skills, for example, to get the text content of a website. I have a skill to create a PowerPoint presentation. One to add a slide with bullet points to a PowerPoint presentation. Another for generating and saving images and generating and saving PDF files. Here, you can basically add any skill you have. Whether it's a skill that performs a task with pure local Python or a skill that connects to a third-party service to carry out an operation. The next section is the Model section. This section is also very important because it will allow you to define which LLM models you want to work with or assign to the agents. You can click here on New Model. Notice that you have many configuration options here. And surely, you would use an OpenAI model. In my case, I defined an Azure OpenAI model. If you click here, you define the model, the API key, the endpoint, the API version, and a description, and you can test the model to ensure everything works correctly. In my case, I've defined this model, which is GPT 4.0 Mini. Here I have the endpoint, the model name, the description, the API version, and the API key. So it's a section that allows you to define all of this. You also have the option to define a local model, for example. Here you could define the model, the API key, and the base URL, which always provides a URL to run it in the browser. So that URL would be the one you would put here to fill in this information. Although you could use this information, this default option that comes as part of AutoGen Studio, to fill it in with your own information. The next section is the agents section, which we see here. This section basically allows us to configure agents that will be used in the agent's workflows. So here it's like defining the roles for a person. Here we will say, okay, you're going to be responsible for writing or creating the outline for an article. You're going to be responsible for refining an article. You're going to be responsible for improving a prompt, etc. How do we do this? Well, we click on New Agent. We see that we have different configuration options here. As far as I remember, we had a user proxy agent. So this user proxy agent comes pre-created by default. So there's no need to create it. What we can create are assistant agents and group chat agents. Let's see what the assistant agent is about. Basically, here we have to save information like the agent's name, description, the maximum amount of auto-responses it can give. Sequentially, how many times this agent can respond if we want user intervention or not, to ask questions in case something is not clear to the LLM. Also, a very important thing is the system message, where we basically define the responsibilities that an agent has to carry out. We have some advanced options like temperature, maximum number of tokens if we want code execution configuration, etc. Once we create an agent, I am creating this one as a test. I will go to the models section, and here we can assign a specific model from those we have previously defined. In my case, I select GPT-4 Mini. The next section we can fill in is the skills section, to equip the agent with skills and use those skills to complete a task. For example, we could indicate that this agent can create images with Azure OpenAI. When we tell the agent to create images, it will use this ability to create that specific image. In my case, I will delete it because it doesn't make sense for the agent to be created this way right now. Another thing you could do, if you wanted, is use an LLM to define the different tasks you want to achieve. For example, here I am showing you a part of the prompt configuration that you could use to create a series of agents using an LLM. Here I am indicating that the properties that interest me are these that we see here. This is because these are basically the different properties requested when we want to create a new agent. The agent's name, description, the message system, etc. So this is all we are going to ask the LLM to generate for us. What's interesting here is that we could even pass the series of skills defined in our system to basically be able to somehow obtain all the different features or skills we could assign to an LLM. Here I have the LLM. So basically what I am doing here, or what I do as part of this LLM, is that I configure the instructions for this agent. These are the instructions I showed you earlier. With this information already filled, I can start a chat conversation and indicate to the LLM, okay. Okay, here I indicate that I want a series of agents that allow me to improve a prompt to generate images through artificial intelligence. And finally, create an image. So, for example, here comes Agent 1, the prompt enhancer, which will basically take a user's basic prompt and enhance it by adding descriptive details, context, creative elements, etc. We see how this helps us a lot, giving us ideas of what different agents we could use as part of a workflow. We have the image generator. Here, notice that as part of the skills, this particular agent, the second one, has a skill assigned, which is generating images using this skill called Generate Azure OpenAI Image Images. Finally, we would have an image reviewer that would allow us to carry out the analysis of the final image. Notice how only the second agent is assigned a skill because it is in charge of carrying out the image generation. With this then, we get an idea of what agents we could create, and we could even reuse this information to fill in each of the agents in AutoGen. In my case, I have already created a series of different agents, one for market analysis, for example, one for writing articles, etc. I might have one called Strategic Planner, which has a description like this and has a system message, as you can see on the screen. So basically, this is how we define the different agents. And finally, we have the section that says Workflow, which basically allows us to configure a workflow of agents to be used to carry out the execution of tasks. This is where we define which agents will be involved in carrying out a task. If we click on this button that says New Workflow, we see that we have a window that says we want a chat window. This first workflow will allow us to create a type of workflow in which a starter and a receiver will participate. The initiator is basically the agent that will start the conversation. In this case, it will usually be you, creating some kind of initial task. We can then indicate that user proxy is the initiator, and the receiver is the specialized agent that performs a particular task. For example, you could indicate that you want it to be Travel Group Chat, which is a set of agents performing a specific task. By the way, returning to the agents, I forgot to mention that in this section you have the group chat, which is basically like the slides I showed you, an agent that handles many agents and decides who takes the turn to perform a task. If we create this particular agent, you will see that we have a section called Agents, where we can add as many agents as we want or need as part of this agent setup. So, the agent will be in charge of selecting whose turn it is to perform the next action. And that is why this workflow here, which we defined earlier, has a travel group chat as a representation of that set of different agents carrying out a task. Now, let's test this workflow that has this pair of. Well, let's first test the default workflow, which essentially has two agents as I showed you earlier. One that starts the conversation and another that executes the tasks. This default assistant, which I will show you quickly so you can see, has the GPT-4o mini model assigned and only has the capability to generate images. So if we go here and say, okay, I need to start this workflow, I want to test it, and if I were to say something like, for example, hello, you can see that very simply and quickly it responds and concludes with the default assistant saying terminate, because it doesn't make much sense to respond to this message. If we go to the profiler, something very interesting is that it shows us all the information about which agents intervened, which tools were used, and what the cost of the LLM was. So if we tell it something like, for example, create a PDF document. Let's see what happens. Okay, back here. In this specific case, it did create this PDF document because the LLM agent knows how to create a PDF file using Python code. In fact, we can review this as part of the response or series of responses we have received. We see that we have 4 messages that were basically created by the LLMs. We see the default assistant response to user proxy with certain information on how to create a PDF document. We see that we have Python code to carry out the installation of a certain library. And finally, the Python code, to which user proxy says, okay, I had a successful execution because it carried out these steps locally. And finally, this is why the PDF document was created without any issues. But if we had another task, such as generating an image, in this case, it will do it because it has the image generation part assigned. We can tell it to create an image of, for example, beer. After a few seconds, we see that the image has been generated satisfactorily. How did this generation happen? Well, we can review the flow. We see that it uses this tool assigned to this particular agent because it knows how to draw an image. So, let's see what the different steps to generate the image are. We see that the query is defined. This call to the function or the skill that we defined earlier is made. We have a failed execution here, and basically information is given to people about what happened. We are given information about the code to execute, and all of this results in a correctly generated image. Okay, as part of these workflows, we have a second workflow called sequential, which basically allows us to create a sequential workflow. What does this mean? Well, I'm going to create it. In this case, when I select different agents, you will see an arrow symbol which basically represents that one agent will execute a specific task after another agent. So, this indicates or allows us to create a sequential flow to define, okay, first you are going to execute this, then you are going to execute this based on the output of the previous one, and so on. This is what defining a sequential workflow is for. Here we have other examples of different workflows, like one that allows us to generate files and PPTX files. We can try it, for example, okay? This will start the process once again. Let's give it a few seconds. After a few seconds, we see that we have a resulting file in PPTX format. Let's quickly review the messages. We see that there are 8 messages. We see that in this case, the skill is used once again to create PPTX files. We indicated it to add PPTX slides. So all this information is used to create the final file called Azure Presentation. Let's find it quickly because we can't do it or the software doesn't have the ability to display PPTX files. So let's look for Azure Presentation. This is the one that was created today. Okay, so here we have the presentation with all the information that was taken or generated from the data we provided. With this, we see that we have a successful flow. But we can have other, more complex flows like one that allows us to write articles. In this case, notice that this is a sequential workflow, going through different agents, which can make it more time-consuming. But let's try it, for example, by indicating, write an article about Bitcoin. Let's wait a few seconds for the execution to finish. After waiting a few minutes, we see that in 1 minute 24 seconds, and after executing 18 messages, we have the final result. We see how each of the different agents is invoked or used, performing the defined tasks like creating the outline, revisions, different drafts, etc. We see the sequence of messages where, in the end, we get a complete guide, including a table of contents, an introduction, historical context, etc. So this is how we can create these types of more complex workflows. We can even create other types of workflows, like those that allow us to know whether it is convenient, for example, to invest in a particular stock. Let's see what it responds. Okay, after some time, we can see we have a result as part of the investigation carried out by the different agents. In summary, it says that Tesla presents an optimistic opportunity, but long-term investors should be cautious if they want to enter the electric vehicle market. So it would be a good tool. Here, it would be ideal to connect some people to the internet to get the latest information about a company's stock, giving us greater security regarding the LLM responses. Finally, in the upper section, we have a section called Playground, which allows us to save chat conversations with different agents, including all related information. Unlike the workflows testing section, where information is not stored, in the Playground, we can save this information for future references, demonstrations, or if we want to recall information. We can quickly return here and see what we did. The AutoGen team also recently released an article showing a new graphical interface they are working on. You can see that this interface is drag and drop. Here we have a couple of agents, or the user proxy and a second agent. Basically, with this interface, we could easily drag new skills to an agent, allowing the agent to acquire those skills more easily. We can find the final interface a bit further down. This interface, which you can see here, looks more modern and allows you to have more information available in a more graphical, visual form, making it easier to find quickly. This graphical interface looks much better. You can see the progress in the official Microsoft AutoGen repository. Currently, this version is at 0.4. You can try it if you want by installing or executing these commands. I installed it on a virtual machine, which you can see on this screen. Here, I have executed the different commands as part of this virtual machine. Here, I have this URL, which I'm showing on the screen. This is basically the graphical interface that AutoGen provides with its preview version. Remember that this version is very immature, so you will have very few configuration options. For example, you only have the playground section, the settings option, and the option for a dark or light theme. If you want to use this system, you can currently create a new theme, which gives you a JSON file where you manually configure all the options we previously saw graphically, currently through the JSON file you see here. You can configure the LLM models, system messages, etc. Surely, in the future, this will change, and you'll be able to define everything via the graphical interface, but for now, you have to do it this way. Once you have this configured, you can select one of the themes and start a new session. For example, select the theme and create. Now you can start asking questions to the LLM agent. Let's see what answer we get. You can see that the initial question was about the height of the Eiffel Tower. And we see the final answer here on the screen. But further down, you have the description or the flow the agent followed to obtain this information. And even on the right side, you can see a diagram showing the different interactions that have taken place. You can see that a cycle was implemented here to conduct the investigation and extract information. We have executed 10 messages to obtain this information. You can download the information or switch to a horizontal diagram. You can hide the labels here if you prefer. You can display the number of tokens if you want this information in a simpler way. It is basically an improved interface that I really like, and I believe it will be one of the applications that will allow us to configure agents quickly and visually. So, I recommend you check out this repository and stay updated with the various changes to keep up with the latest developments in AutoGen. Well, this brings us to the end of this session. I hope you liked it and found it useful. I also recommend continuing to explore and installing it locally so you can try it out. So, farewell. My name is Hector Perez. Here's my handle in case you want to follow me on Twitter. See you in the next video.